Hey everyone, welcome to another lecture in the DSA series. So this lecture is in continuation with the previous one in which we discussed about stack applications. So in this as well, we will be discussing about one more application which deals with expressions. So it will be expression conversion and evaluation using a stack. So let's get started. So when it comes to expression, what exactly expression is? So it's a combination of operators and operands. Okay, and what exactly a operand is? These are variables or constants. Either it can be a, b, c variable or constants 2, 4 and so on, and the operators. So operators, so to keep the discussion simple and easy to understand, we are only considering 4 or 5 operators, which are plus, minus, multiply, divide, and you can also consider the power or the exponent. And we will be dealing only in binary operators. Okay, so for instance, a very simple and basic example, say you have 2 plus 3. So in this is an expression in which 2 and 3 are operands. 2 and 3 are operands, and this plus is operator. So expression basically is a combination of operand and operators. Okay, so this every operator has a specific meaning associated with that. In this case, 2 plus 3 is a simple addition of these two operands. So the answer is 5. Okay, so this is a very simple or elementary example of what exactly an expression is. Okay, so this straightforward expression, so you can have like various example. For instance, this 2 plus 3 times 5 minus 1 is also an expression. So in this expression, we can easily split out what are operands and what are various operators present in this. So what are operands? In this expression, 2, 3, 5 and 1. There are 4 operands. Okay, all are constants, no variables. And when it comes to operators, we have plus, multiply and subtraction. So 3 operators. Okay. So similarly, given expression, you can easily figure it out what are the operands and what are the operators that are involved in the given expression. Okay. Same as we have another example. Okay. In this, if you have to find the operators and operands, starting with operands will be 6, then 2, then 3, then it will be 4 and 2. And when it comes to operators, it will be division, second is subtraction, then a multiplication, asterisk, and finally a plus. So it has 5 operands and 4 operators. Okay, so generally when it comes to operators dealing with binary operands, okay, so the number of operands will be 1 greater than the total number of operators that are present in an expression. Okay, so now there is a certain precedence and associativity that are associated with these operands. Okay, you might have already we have already covered it in the programming lecture in which we discussed the operators and their precedence and associativity, but it is a small revision. So generally parentheses are not considered as operators. These are not considered as operators, but when it comes to evaluating the value of an expression, it is having the highest precedence. Okay, from all these operators, you always go ahead and simplify whatever expression present in the parenthesis before applying it over the operators. All right, so the next to the list is exponent. So exponent will be having the highest precedence and the associative will be from right to left. What is associativity? It is basically if a exponent b exponent c is given to you, so you will evaluate this. It will give us, it will give you a some value and then this, right to left. Okay, then comes asterisk and division. Both will be having same precedence, but the associativity will be from left to right. So what it means, so if for this instance, if it is given to you 2 asterisk 3 by 2, so you will evaluate this first. Both the operators will be having same precedence, multiplication and division. So it will be 2 by 3 first evaluated, then divided by 2. So you will evaluate it later on. So associativity tells you, given the same precedence in like of multiple operators in an expression, what will be the order in which you will be resolving it. And finally, plus and minus will be having the least among all, the one which we already discussed, exponent, asterisk and division, and associativity will be from left to right. So in this example A, this expression, what will be the value of this expression? 2 plus, if the expression is 2 plus 3 times 5, 2 plus 3 asterisk 5 minus 1. So based on the operators present in this precedence table, what will be the operator that we will be resolving first? Asterisk, right? So we have only 3 operators, plus, asterisk and minus, among which asterisk will be having the highest precedence. So we will be evaluating this first. So it will give us value 2 plus 3 times 5, which is 15, minus 1. Okay. So now only we left with 2 operators, plus and minus, having same precedence. So associativity kicks in. So it will be from left to right. Whichever operator is present on the left hand side will be evaluated first. In this case, we will evaluate 2 plus 15. It will give us 17 minus 1. Finally, only one operator is present. It will give us the value, which is 16. So the value of this expression, example A, will be 16. But when it comes to evaluating the value of expression B, you can't evaluate it straight away. Why? Because this is another form of representing the expression. Total we have 3 forms. We have 3 common notations of expressing these, of writing these expressions. The first is the most general one, which is also human simplifiable directly, which are infix expression. The first one is infix expression, in which the operators are always in between the operands. Instance 2 plus 3. 2 is an operand, 3 is an operand, and plus is an operator. So if the operator is in between the operands, that expression will be called infix expression. And this is true for all the operators and all the operands present in that specific expression. So every operator should be in between the operands. That's it. For instance, if A and B are 2 operands and plus is the operator, this is the infix form, A plus B, where operator is in between 2 operands. Okay. Next comes prefix, also known as Polish expressions. What it is? It is when operator is before the operands. So you can associate it with this, the word pre with the operator. So if it is prefix, the operator will be first. If it is postfix, the operator will be at the end, post the expression. Operator will be post the expression or towards the right of the operands. Okay, so prefix will be operator before operands plus A and B. Plus is the operator, A and B are operands. Postfix, also known as reverse Polish, the operator will be after the operands, A, B, plus. So if I have to ask you, example B, what type, in which category this example B lies? So straight away it is not in infix. It is not in infix. You see 6, you see 2, and then there is a division. Okay. So it is not infix. The operator is on the right hand side of these operands. Is it prefix? Is it prefix? If I only have to give you 6, 2 and division, is it prefix? No, right? Why it is not prefix? Because in prefix the operator is always before the operands. In this case it is after the operand, so it will be the postfix expression or reverse Polish. Okay, clear? So these are three different ways in which these expressions can be written or annotated. All right, so now let's see how you can convert, because like infix expressions are human readable. We can easily calculate the value based on what the expression is. But when it comes to computers, generally postfix and prefix are preferred, and a stack is used to compute the value of that expression. So we'll see it in some time how stack is used for these conversions and evaluations of the value. First, let's discuss conversion. So given infix, given postfix, given prefix, you can convert the expression into any form. So we will be discussing all conversions. So you have infix, you have postfix, and you will be having prefix. So first we will discuss how a infix can be converted to postfix. This is converting a infix to postfix. Okay, and this algorithm it's a very popular algorithm known as shunting yard algorithm. So first we will discuss converting infix to postfix, then infix to prefix, then postfix to prefix, prefix to postfix, and finally postfix to infix and prefix to infix. So we will discuss all 6 possible conversions that you might required in order to convert one expression into another form. Okay, so let's start with this. So this algorithm, let's first go through the algorithm and then we'll take an example which is an infix expression and convert it into its corresponding postfix form. Let me move it. All right. So the algorithm is pretty simple. So the let us discuss simultaneously the algorithm and the example. So let's assume this infix expression is given to you. I'm writing it down in an array so that we can traverse it character by character. We can traverse it character by character. So starting with parenthesis, then you have A, then it's plus operator, then B, then parenthesis closed, then it's asterisk, parenthesis open, then it's C, minus, D, and finally the parenthesis is closed. Okay, so this is what the given infix expression to you. So the algorithm starts step number 1. For each token in the expression, you have to iterate over each character starting from the first one. We will iterate, will traverse the given infix expression character by character. Okay, so some characters will be parentheses, some characters will be operands, and some characters will be operator, and the behavior of the algorithm will change based on what is the value of the corresponding token. Okay, so there will be a for loop for each token in this expression. Line number 2, if it's an operand, okay, so it can be either an operand, parenthesis, or an operator. All 4 scenarios are mentioned. All right, it can't be other than this. So if it is an operand, you add it to output. Output is the string. Output is the empty string. Output is a string which will be returning. So initially its value is empty. So what line number 2 says, if it is an operand, you just add it to the output. So in this case, it's the parenthesis. So it won't be get added to the output. So what if you get the parenthesis, line number 3, if it is a parenthesis, push it to the stack. So we will take an empty stack, the stack will be empty initially. So the first element that we will be pushing in this stack will be at line number 3, which says if it is a opening parenthesis, just push it in the stack. So this will be pushed in the stack. So once this else condition executes, so the later conditions, which is else or the second else or the third else, won't get executed, and we will move on to see what is the next token in the expression, right? So after pushing it over here, the next token is A, and this is an operand. This is an operand. So you will straight away, whenever you see an operand, either it is a variable or a constant, you straight away add it to the output. That's it. So the output will be having A, and we'll move on to the next iteration. We'll increment the counter. So now it's an operator. Next one is an operator. So it is neither an operand nor parenthesis. It is, so line number 5 will get executed. Else, if it is an operator, in this case it is exactly an operator, plus. So what we will be doing, there will be a while loop while stack is not empty. In this case it is not empty, and the precedence of the top. What is the top? The top is in this case top is an opening parenthesis. And I already mentioned it in the previous slide that parenthesis, we won't be considering it as an operator in these algorithms. Okay. So this while will only execute when the stack is not empty, which is not empty in this case, and the precedence of top is greater than equal to the precedence of the corresponding token, which is plus. So since this is not an operator, so this condition is false. Both the first is true, but after this and the precedence of top, since the parentheses are not considered as the operators, so the scenario of precedence won't occur. So this second condition will be false. So this while won't get executed. So nothing will be popped from the stack. So we will straight away move on to line number 7. This while is false. So the next line that will get executed will be line number, it's 8. It's line number 8. Okay. We will push the token in the stack. This is the token which is an operator. So this plus will be pushed to stack. That's it. We'll move on to the next iteration, which is another operand. Now, whenever you see the operand, line number 1, line number 2, add it to the output. Add it to the output and move on. Add it to the output and carry on the operation. So now it's a closing parenthesis. We see a closing parenthesis. So line number 4 will take the charge, because it is neither an operand nor an opening parenthesis. In fact, it's a closing parenthesis. So we will pop until you get the opening parenthesis. We will keep on popping until you get the opening parenthesis. And whatever the element is popped out will be added to the output. So pop will always add it to the output. Let me add it over here. Pop until pop and add to the output. Okay. So the first element that will be popped will be an operator. We will pop it, add it to the output, AB plus, right? And the termination condition is pop it until you see the opening parenthesis. So you will pop it again. But yeah, since any prefix or postfix expression, you won't see the parenthesis in that. The parentheses are only for the infix expressions. That's why they are ignored when it comes to the postfix and prefix. So we won't be adding them to the output. Okay. So then the next iteration will be a asterisk, and the stack is empty at this point. So when you see an asterisk, condition number 1, it won't get executed. The second won't get executed. It is not an operand, not a parenthesis, opening parenthesis, neither a closing parenthesis. It's an operator. And in the while condition, stack is not empty. If it is not empty, in that case the condition will be true, but in this case the stack is empty, so the while is false, so nothing will be popped from the stack because it's already empty. So line number 8 will get executed. You will push the token, you will push the operator which is asterisk in stack. So next element that will be pushed in the stack will be asterisk, and you increment. Now it's a opening parenthesis. You already know what to do. Push it in the stack. We'll push it in the stack. Now it's a operand. When you see an operand, just add it directly to the output. So C will get added to output, increment. The next is a operator which is subtraction. So straight away, line number 5, it's an operator. Check the stack whether it is empty or not. The stack is not empty, but the precedence of top is not greater than equal to the precedence of the token. Why? Because token is an operator and the top of the stack is a parenthesis, so it's like a non-comparable thing. So while becomes false, straight away move to line number 8, push the token. Token is minus. The minus will be in this stack. Increment. Next is D. Again, it's line number 2 that will get executed. It's an operand. We'll add it to output. D will be added to the output. Finally, the last character or the last token of this infix expression, which is the closing parenthesis. So once you see a closing parenthesis, you pop, and whatever is getting out from the stack, you keep on adding to the output. Okay, until you find the corresponding open parenthesis. So this will be popped and added to the output. Again, this will be popped and we will ignore it. And finally, the last one, which is the terminal state when this for loop ends. When this for loop ends, line number 9 and line number 10 will be important. Why? Because what it says is whatever present in the stack, you just pop it out to ensure that stack is always empty when the program terminates. So in this case, we will be having a asterisk in the stack. So line number 9 says while stack is not empty, just pop the elements and put it in the output. So in this case, there is only one element, so this will be popped at the end. This will be popped at the end, and you will add the asterisk to the output. Okay, so since the stack is empty now, you can return this output, which is the postfix expression of this infix. So we have successfully converted infix expression to its corresponding postfix form. This is the output that will be returned from this algorithm. Okay, understood? So the idea remains the same. It will be more clear when you try to solve like different examples, different scenarios. So you will be fast in these conversions and it will be clear. Again, on a broader way, there are 4 conditions. Either it will be an operand or opening parenthesis or closing parenthesis or an operator. In either of the case, if it is an operand, just add it to the output. You not need to do anything. If it is an opening parenthesis, just add it to the stack. If it is a closing parenthesis, keep on popping elements out until you see the corresponding opening parenthesis, right? And if it is an operand, you need to check the stack. If the stack is not empty and the element which is present in the top of the stack is an operator having a higher precedence compared to the corresponding token that you are comparing with, then just pop it out. Keep on popping. It can be like one operator, it can be multiple operators. Just keep on popping till this condition holds, which is the precedence of the top is greater than equal to the precedence of the corresponding or the current operator that you are seeing. And once this while becomes false, you come out of the loop and add the operator of the lower precedence in the stack. So this is just to ensure that there is no scenario in which an operator which is having a lesser precedence present on the top of a operator which is having higher precedence. That's it. Okay, so it is what the logical meaning of this while is. And finally, when you are done with the while loop, or when you're done with this for loop, initial for loop, the infix expression is like you have already traversed all the tokens. You just check the stack. If it is empty, return. If it is not empty, keep on popping it out and adding it to the output. That's it. Okay. So now let's see the next conversion. The next one is, if you have the infix expression, how to convert it into the prefix one. So shunting yard is to convert an infix to postfix. This is to convert infix to prefix. So this is also a simple algorithm. A slight tweak in shunting yard. Let's see step by step. So step number 1, you reverse the infix expression. Okay, we'll see with a simpler example. Let's suppose the infix expression that you have is a plus b. Okay, and like by this time you already know that if a plus b is the infix, the postfix will be, what will be the value of the corresponding post conversion? And like you do not require the algorithm to solve it out. It will be a b plus, right? You just move the operator towards the right. And what will be the value of prefix? It will be plus ab. So we are dealing with the second conversion. Given this a plus b, how you can get plus ab? Given an infix, how you can convert it into a prefix and get the required prefix expression. So the first step is to reverse the infix expression. Step 1. Reverse. What you will get? You will get b plus a. You just read it from right to left. You will get b plus a. So you will get, the value will be b plus a. Right? Now you have to convert this expression which you get after reversing the original infix into postfix. Second step is to convert this to, this is step 2. Convert to postfix. And postfix conversion is the shunting yard algorithm that we already discussed. So this b plus a. So if the original, assume that the original expression that you have was b plus a. So what will be the corresponding postfix of this? You just take the operator, move it to the right. It will be b a plus, right? So it's a simple like a infix to postfix conversion, given b plus a is the infix of expression to you. So you can do like step 2 to get the postfix expression of the reverse infix of the original that you have. Now comes the third step. You reverse it again. The third step is reverse it again. Step 3. Reverse it again. Reverse b plus a. What you will get? You will get plus a and b. And this is what exactly the infix, this is exactly the prefix of the original infix, plus ab. Okay. Third step is reverse it. This will give you the prefix expression. So it's a 3-step simple process. Given you already know how to convert an infix to a postfix. You take infix, reverse it out, convert it into postfix using shunting yard algorithm, and finally reverse it out to get the prefix of the original infix expression. That's it. Alright. We can solve, like have a simple example. Let's solve it for a plus b asterisk c plus d. Right? Step by step. So the original infix expression is a plus b times c minus d, right? Convert it into, we need to convert prefix. We already took this, like we already seen this conversion, like we already seen the conversion from infix to the corresponding postfix for the same expression. Now let's convert it into the prefix. So the three-step process. Step number 1, reverse it. Let's say it was I. So reverse expression I. What it will give? It will give us D minus C in parenthesis times B plus A. Right? This is what it will give us. Now move on to the second step. Step number 2. Convert it to postfix. Let's call it I inverse or like I dash. Let's call it I dash. So I dash is the reverse of the original I. What the second step is, we need to find the postfix of this I dash. So we can easily do it. I dash is, it's D minus C times B plus A, starting with the first parenthesis. So let me form the table. It's up to you. You can like take a stack, or you can like form this table, whichever way you are comfortable with. It's token, then stack, and finally the output. Okay, starting with the first parenthesis. It's a parenthesis, so I will be pretty quick in this case. Just add it to the stack. Output will be empty. Then it's D. It will be parenthesis. Output will be D. Then minus. Whenever you see minus, it's an operator. Put it in stack. Output will remain as D. Then C. So it's parenthesis minus C is an operand added to the output, right? Then the parenthesis is closed. It's a closing parenthesis. Whenever you see the closing parenthesis, you keep on popping whatever present in the stack until you see the corresponding opening one. So this will be popped and this will be popped. Both will be popped and the stack will be empty. The first minus will be put in the output. Output will be D, C, minus, right? So the next is asterisk, and stack is empty. It's an operator. It will be pushed to the stack. Output remains the same, D, C, minus. Then comes the opening parenthesis. Opening parenthesis, just simply add it to the stack. Output remains the same. It's D, C, minus. Then it's an operand, B. The stack remains same. You will add it to the output. Next is plus. So when this plus arrives, you see the stack, it's the opening parenthesis present in the stack, no operator. So simply push it to the stack. Output remains the same. It will be D, C, minus, B, right? Then comes A. So A is an operand, no change in stack. It will be D, C, minus, B, A. And finally, the closing parenthesis. The closing parenthesis. So upon seeing a closing parenthesis, this will be popped, this will be removed from the stack. So plus will be added to the output. It's D, C, minus, B, A, and plus. Correct? And finally, since like the traversal is already, the initial for loop is already like completed, so now you left with the last part, which is check whether the stack is empty or not. If it is empty, return. If it is not empty, keep on popping the elements out till it becomes empty. So in this case, stack is like only having one asterisk, so we'll just pop it out and add it to the output. It's D, C, minus, B, A, plus and asterisk. So this is what the postfix of I dash will be. So postfix of I dash, postfix of I dash will be DC minus BA plus and asterisk. So this is step number 2. So we completed step number 2. We successfully got the postfix of the inverse infix of the original expression. Now the last step, step 3. Step 3, reverse this postfix. Reverse it again. Okay. So this will give us the infix, not infix, this will give us the prefix. The prefix expression of I. The prefix of I. It's the reverse. Just reverse it out. Read it from right to left. So it will be asterisk plus A, B minus C and D. So this is the infix that we need to return for the corresponding, this is the prefix that we need to return for the given infix expression. So step number 1, reverse the original infix. Step number 2, find its postfix. Step number 3, reverse it again in order to get the prefix of an infix expression. Alright. So that's how you will be dealing with these sort of conversions. So till now we already covered infix to prefix and infix to postfix. So in this slide, let's have one more conversion when you have the postfix expression. So either you want to convert it into an infix or a prefix, and this algorithm is also will be the base. It will form the base of expression evaluation. So this is the conversion algorithm, but the evaluation algorithm is also pretty much simpler, only like a very small change in order to have a evaluator and not a converter. Okay, but this is for the conversion from postfix to either infix or prefix. All right, so let's get started. So let's assume you have a postfix expression. It's a plus ab plus c asterisk, and we need to convert it into the corresponding infix expression. This won't be the infix, minus and d won't be there. So the infix of this expression, the infix of a, b plus c star, this is postfix. We need to find the infix, which will be a plus b asterisk c. This is infix. So we will be seeing how you can convert a postfix to either infix or like prefix. The algorithm is like pretty much same. So starting within, the first step is to create an empty stack. Okay, so let's assume you have the empty stack. Okay, all right, so this is your stack. Initially stack was empty. So the only difference in this algorithm compared to the shunting yard algorithm is that you will be pushing operands. We will be pushing operands in this stack, not the operators. Okay, so for each token t in the postfix expression, so we will be iterating over this postfix. So let's have an array, a character array of the original postfix a, b plus c and asterisk. That's it. So starting with this, starting with a, if t is operand, if it is an operand, in that case you will push it to the stack. In this case a is an operand, so we will remove it and put it in stack, right? So else part won't get executed. Again we'll move on for the second one, b. Again it is an operand. Remove from here, put it in the stack, right? Then iterate again, it will be plus. Now it's an operator. Now it's an operator. So if it is an operator, which is the else part, line number 5 will get executed because T is now an operator. Okay. So whenever you encounter an operator, you will have to perform two pop operations. We will be performing two pop operation. The only important thing with these pop operation is that the first pop operation will give you the second operand and the second pop operation will give you the first operand. Okay, why? Let's see. So the first pop, here we have added A, then we have added B in this stack, right? So let's have a very basic example. So what if the original postfix was just as say A, B plus, okay, the basic example that we seen earlier as well. So the corresponding infix of this expression is A plus B, right? Okay. So the order in which we will be putting, we are traversing this from left to right. This is the first element, this is the second element, and this is the third element, right? So the order in which we are pushing the elements in the stack is from left to right, correct? So we are pushing A, then we will be pushing B, and then when plus encounters, we will pop two elements and perform the operation, right? So the second element or the last one which is added to this stack will be on the right hand side of the infix expression. In the postfix, the last or the latest element or the latest operand that is pushed in this stack will be the right hand side operand of the infix expression, right? So if I need to evaluate or like if I need to convert this simple postfix to infix, so the first pop will be my right hand operand B, the second pop will be my left hand operand A, and then the operator will be in between them, correct? So that's why, like, do ensure that the first pop that you are making will be the second operand and the second pop will be the first operand. This T is what the operator is. In this case it's plus, it can be anything, it can be plus, minus, you can take any operator. Okay, so this was the important point that you need to consider when you are converting a postfix to infix, right? And when you are converting a postfix to a prefix, the only difference is in line number 8. Okay, so if you are considering this expression, this will give you infix. Okay, and if you are considering this expression, you will get the prefix, right? So if you have operand 1 plus the operator plus the operand 2, it will give you the corresponding infix expression. But if you do the pop in the same order and you just have the operand first, which is plus A and B in this case, this is not like, this is exactly what a prefix of AB plus will look like, correct? So the only difference, so postfix to infix, use this expression, postfix to prefix, use this expression at line number 8, rest everything remains the same. So let's continue with this. Yeah, so we were here, so now we need to perform two pop operation. The first pop will give us the right hand side, okay? The first pop will give us this B, the second pop will give us A, and the operator in between will be plus. This will be the operator. Okay, so this expression value at line number 8, if I am converting a postfix to infix, will be parenthesis operator 1, the operator operand 2, and then the parenthesis closed. So expression will be parenthesis A plus B, right? This is exactly the value of expression at line number 8 will be correct. So now the next is push this expression again in the stack. So what we'll do, we'll take the value and push it again in the stack. The stack will be having now A plus B. This is the only element present in the stack at the top, correct? And we'll keep on continue. So this is also crossed. The next is C, and C is an operand. Whenever you operand, just push it. So we'll push C. So this is also gone. The last is asterisk, which is an operator. If we find an operator, first pop will give us the second part. So now the second expression will be, this will be the first pop. C will be at right hand side. C will be right hand side, which is operator 2, operand 2. Then the second pop will be A plus B. It's A. It will be A plus B in parenthesis C. Okay. So this is OP2. This is OP1. Correct. And the operator will be asterisk. Right. There will be an asterisk in between. So this is EXPR. Next step is to push it. Again, you can like have these parentheses. So now this EXPR we will be pushing on the top of the stack. It will be A plus B asterisk C. Right? So now the iteration is over and we will come out of the original for, which is line number 2, and we'll just return the first element on the stack, which is in fact the infix expression that we want to evaluate. So this is the answer. We will pop it out, and this is the infix expression, right? So postfix to infix, similarly postfix to prefix is also simple, right? Rather than A plus B, if you want to calculate infix, it will be plus A B. Then this plus AB will be at this place, and when you are performing, when you encounter the second operator, so the two elements that will be popped from the stack will be plus AB and C, right? And this expression, the second one, would be like this, asterisk. It will be like this, asterisk, then A plus AB and C, right? Plus AB and C, and this is the only element present in the stack. We'll pop it out. This is the corresponding prefix expression. All right. So now you can easily convert a postfix either to infix or to prefix. All right. So now let's see the final conversion, which is if a prefix is given, if a prefix expression is given, how can we convert it or get a infix or a postfix from the prefix? Okay. So now let's convert the same infix expression I am taking, which is asterisk plus A, B and C. So more or less the algorithm remains the same, only two differences. The first, whenever a prefix expression is given, no matter whether you want to convert it into an infix or a postfix, you always scan it from right to left. You always scan it from right to left. Or you can also do like reverse the string and then like scan it from left to right. Both are same. Okay. So this is the infix expression. Not infix, it is the given prefix. So the prefix is asterisk plus ABC. So it is more or less the same thing. Either you reverse it, traverse from left to right, or scan from right to left. Okay. So let's have an array for that. So the values will be putting it starting from right, C, then B, A plus and asterisk, and this will be the first value of token or T that we will be scanning, right? So now if the idea remains the same, if it is an operand, push it. If it is an operator, then pop it. The second difference, the first is you have to scan from right to left. The second difference is this. The first element that you will be popping, would be the left hand operand. The second element you will be popping would be the right hand operand. Why? Because we have already reversed the string. We have already reversed it. You can think of a simpler example. In this case, if you assume that the prefix expression is like a plus a b, okay. So if you are scanning this prefix from left to right, the order in which you are pushing the elements in the stack would be first a will be pushed and then b will be pushed, right? So it will make sense if you pop b and put it on the right hand side of the expression. It will make sense. But since you are like scanning from left to right and you are pushing the operands in the stack, so b will be first, that will be in the stack. In this case, b will be first and then a will be there. And then you encounter this plus. Whenever you encounter an operator, you will pop it out, the first element. The first element is in fact the left side of the operator in the converted infix expression. So a will be here, then plus, then b will be there. The first popped element would be on the left hand side of the operator. That's why in this case, when you are converting a prefix to infix or postfix, the first pop will be the left hand side, the left operand, the second pop will be the right operand. But if you are converting a postfix to either infix or prefix, in that case the first pop element would be the right hand side operand. So keep this in mind. Okay. Alright, now come back to the original problem, which is you are scanning this prefix and you need to convert it into the infix expression. So again, we'll have to consider an empty stack. So let's have it here only. So this is the stack that we have. Stack S. Okay. Just call it S. Initially it will be empty. So when you encounter an operand, just push it in the stack. So the first value will be C. Then we'll check B, push it in stack. Then A, push it in stack. Then you encounter the first operator. This is the first operator that we encounter while traversing this expression. So whenever an operator is there, if T is an operator, you pop out two elements. We will be popping out two elements. The first will be the left hand side of the expression and the second one would be the second operand. So two consecutive pops. The first pop will give you, so OP1 will be A. The second pop, OP2 will be B, and the value of expression will be operand 1, operator, operand 2, enclosed in parenthesis. If you are trying to find the infix expression, if you are trying to convert it into the postfix, in that case operand 1 plus operand 2 and the operator. Okay, so this you will be using this expression for infix conversion and you will be using this expression for postfix conversion. Alright, so in this case let's look for infix conversion, prefix to infix. So the expression will look like A plus B, right? So once you get the expression, enclosed in parenthesis, once we get the expression, the next operation is to push it again in the stack. Why? Because we are still like traversing or reading the array. So this will be pushed, the value will be A plus B. Alright. So now this is also will be crossed. The last one, which is asterisk, we cross it out. We perform two pop operations from the stack, OP1 and OP2. What will be the new values? In this case, the first popped element will be OP1. It will be A plus B in parenthesis. The second one will be this C. Okay, and the expression will be A plus B asterisk C. You push it again to the stack. It will be A plus B asterisk C. Right? And then once this for is done, we'll move on to the next line, line number 10, and pop the topmost element and return. It is the corresponding infix expression of the given prefix. Okay, we have successfully converted. So this is the infix expression. Similarly, you can have the postfix as well. This expression in case of postfix will look like OP1 operand 1 operand 2 and then the value of operator A B plus, right? And this expression, the above one, will look like OP1, which will be AB plus then C and asterisk. Okay, so this infix, if this is the prefix, A plus B asterisk C will be infix and AB plus C asterisk will be the postfix. This is how you will be dealing with all these conversions. So far, if we have infix and we have postfix, so far we have seen how to convert an infix to postfix, how to convert a postfix to infix, how to convert an infix to prefix, prefix to infix, postfix to prefix, and prefix to postfix. All these 6 conversions now we have covered. All right. So now let's see the evaluation part. So we will be discussing only 2 evaluations. The first will be postfix evaluation and the second will be prefix evaluation. So this will be A and B will be prefix evaluation. We won't be discussing infix evaluation, but because it is pretty straightforward. Since childhood in the basic mathematics, we are evaluating the infix expressions only. For instance, if this 2 plus 3 multiplied by 5 is given to you, it's an infix expression. You already know how to evaluate and get the answer. Okay, first calculate this value. It will be 2 plus 15 and then have an addition. It will give you 17. So it's a very trivial operation, so we won't be discussing it. But if a postfix expression is given to you, which is, for example, this is given to you, so it is like it is not that easy or not that intuitive to directly calculate or evaluate the value of this postfix. And same holds for prefix. So we will be discussing how we can convert, like how we can evaluate the values of these expressions. Okay. All right. So given the postfix, so the algorithm remains the same. So we have discussed 2 algorithms just before this, the prefix to infix conversion and postfix to infix conversion. So the evaluation is also similar to that. The only difference is at this step. So in the previous two algorithms, we used to evaluate the expression and then push it in the stack. In this case, we won't be evaluating the expression since the constants are given to us. So rather than evaluating rather than just getting the expression, we will solve that expression. We will solve that, and then we will only push the result after we apply this operator on these two operands, and same holds for prefix evaluation as well. Okay, the entire algorithm remains the same. So we will be starting with empty stack. We will be iterating over each character or each token in this postfix expression. If there is an operand, we push it, or else if it is an operator, we will be doing two pops. The first pop will be the second operand, the second pop will be the first operand. We'll calculate the result, we evaluate the result, and then push it back to the stack, and we will repeat it until the string is over. And finally, the top element of the stack will be the evaluated value, the value of this postfix expression. Okay, so let's have an example. So this is the postfix expression that we have, starting with 6, 2, then division, 3, subtraction, 4, 2, asterisk, and finally addition. Okay, so starting with this 6, and then you have an empty stack which will be used to evaluate this expression. We'll cross it out. Since it's an operand, we'll put it in the stack. Second, again it's an operand, put it in stack. Now it's the first operator. Whenever you encounter an operator, two consecutive pops in such a way that the first pop will be operand 2, the second pop will be operand 1, the value is 6, and the result will be operand 1, the value of operator, and operand 2. So it will give us what? R stands for result. It will be 6, the operator is division divided by 2, 6 divided by 2, and the value is 3. Whatever the result we are getting after evaluating, again we will push. Okay, so 3 will be the only element that will be added on the top of the stack, this push. Okay, then this will be crossed. The next one is 3, then the next will be a subtraction, and it is an operator. If we encounter an operator, perform two pops, the first pop and second pop. In this case both are same, so will be both as 3. The operation is subtraction, so the result will be 3 minus 3, which is 0. So this 0 will again push in the stack. So stack will be having 0. Alright, so next is 4. Next is 4. After 4, it's 2. Then it's an asterisk. So again, if it is an operator, perform two consecutive pops. Remove this, remove this. The second one will be the first pop 2, and then this will be 4. What will be the value of R? Result will be 4 times 2, which is 8. Push it back. So 8 will be there. Again, the last character or the last token present in this postfix expression is addition. So finally, the last operation will be, this will be the first pop and we have 0 and addition. So it will be, the result will be 0 plus 8, which is 8. This 8 again will be pushed in the stack. So this will be there. Okay. So we are done with this for loop, and finally line number 10, we will return the topmost element, which is the only element, and the value of the postfix that we have started with. So this will be popped. Value of the initial postfix expression. The answer is 8. Okay, so given a postfix expression, using this algorithm, you are using this technique and a stack, we can easily evaluate its value. Alright. Similarly, we can do the same for evaluating prefix expressions as well. Okay, so let's see the prefix evaluation. So let's assume we have this expression for example. Okay, so algorithm remains the same. We will be scanning from right to left, or reverse it out, scan from left to right. We need to note this. The second is, again, the first pop will be the left hand operand, second pop will be the right hand operand. So it is the same. And line number 8, which is, we won't be like evaluating the expression since these are constants. Directly get the result and push it again in the stack and continue the process until the string or the expression terminates, right? Okay, so the starting array or the tokens will be read from right to left. So 9 will be the first, then 4, 5, asterisk, 3 to asterisk, plus and minus. That's it. Okay, and we'll be starting with 9, and initially the stack will be empty, right? So let's have the stack. Initially it will be empty. Okay, so this is 9. The algorithm is same. If it is an operand, push it. If it is an operator, 2 pops, perform the operation, get the result, push it back again in the stack. Do this for the entire expression. So the first 9 will be pushed, removed from this. The second one is 4. Again, we'll push it. Then 5, push it back in the stack. Then it's the first operator, which is asterisk. Whenever you see an operator, perform 2 pops, get the result, push it back in the stack. 2 pops will give us 5 and 4. The first pop will be the left hand operand. So value of result I'm directly evaluating. R is 5, which is the first pop, times 4. 5 times 4, it is 20. Push it back in the stack. Correct? Now the next one, 3 and 2. Push it in the stack. It will be 3, then 2. Now we encounter a asterisk, which is an operand, which is an operator. 2 pops, 2 and 3 will be removed. What will be the value of result? It is 2 times 3, which is 6. Push it in the stack. 6 will be there. Correct? So this is also done. Then again one more operator, which is plus. 2 pops. First will be 6, the second will be 20. First will be 6, second will be 20. What will be the value of R? Result will be 6, the value of operator, which is plus 20. It will give us 26. Push it in the stack, right? We are done with this plus. And finally, the last one is a subtraction. The last one is a subtraction. And we have two elements. This will be the first pop and 9 will be the second pop. What will be the value of R? 26, which is operand 1. The value operator subtraction in this case minus 9, right? So 26 minus 9, what will be the value? 17. Push it in the stack. And the for terminates. Okay, and we left with only one element. Will pop it out and return. So this 17 will be the value of the prefix expression. Alright, so this is how you will be evaluating the value of either postfix or prefix. Infix is pretty straightforward. Alright, so let's see the demo. Now let's discuss the infix to postfix conversion. Right? So what do we have? We have an infix expression, which let's try to understand this with a basic example. We have this A plus B under parenthesis. This is my infix expression, right? I need it to convert to a postfix expression, which will be look like this: A, B plus, and we already know how to convert this logically, right? Let's see how we can code it out. Okay. All right. Let's define a function into post, which you take an expression as an argument, right? Now we will be maintaining two arrays in this. We will be maintaining two arrays. Why? First, we will be maintaining two lists. First, the stack, which is responsible to store the operators for the operators. Second, for output, whenever we see an operand, we just put it to the output, right? So this is what the shunting yard algorithm is. We are implementing that only. All right, so let's name them output and stack. You can name it anything. Initially both of them will be empty. So output is for final result, which is my converted postfix expression, and stack is for the intermediate stack that we'll be using to push to perform the conversion, right? This will be the intermediate stack. Okay, so what is the algorithm? The algorithm starts with traversing the expression character by character, right? So there will be a for loop in. So we are like heading with an assumption that all the operators are single digit. All operators are single digit, correct? So we are not breaking the initial expression, we are just traversing it character by character. So the first part would be whenever we see an operand. So the first, there will be different if conditions. So the first control will be what if the token is an operand. What if the token is an operand? And what is the definition of an operand? The token looks like this. Token is, say, capital A, 1, etc. This is what operand is, right? What if the token is an operand? In that case, we have to add it to the output, right? So this is how the algorithm works. So let's assume we have this A plus B, right? I'm not talking about the parenthesis case. So let's only have this as the initial infix expression. So now whenever the operand, whenever we encounter an operand, we straight away remove it and put it in the output. The output will be initially empty. So after seeing A, the output, we will add A to the output, correct? This is like how the algorithm works. So we have done the same thing. So now the question arises, how will you identify that the specific token is an operand or not? So for that, we have the inbuilt string utility in Python called as is alphanumeric. So whenever the token is containing alphanumeric characters, then this will be true. Is alphanumeric will be true for all alphanumeric characters. So if it's a token, neither parenthesis nor operator, this will return true. Okay. So this will be false for either parenthesis, any open close parenthesis, or operator. Okay, or else you can also decide this based on the ASCII characters. Both are fine. So now the next part. So we have one condition is sorted. What if the token is an alphanumeric character or the operand? Correct. Now there will be three scenarios. Either it can be a opening parenthesis or it can be a closing parenthesis. The third, it is an operator. So let's see one by one. The second would be else if condition. If the token is a opening parenthesis. So what we do, we'll just simply append it to the stack, right? Just add it to the stack. That's it. So for opening, so this is how the algorithm works. So we have this A plus B wrapped under parenthesis. Whenever the opening parenthesis is arrived, we will push it in the stack. We'll push it in the stack. Then we'll increment. We'll see the next character. In this case, it is an operand. Whenever we see an operand, add it to the output. It will be A. Then it's a plus. We haven't added the condition for operators. Hold on for this. So we'll see what we need to do in case we encounter an operator. Then it will be B. We'll again add it to the output. Then again, finally the closing parenthesis. So now the two conditions are remaining. First is what if we encounter the closing parenthesis. Second is what we need to do in case we see an operator. So let's see. So in case of a closing parenthesis, what the algorithm says, in case of a closing parenthesis, what if we encounter a closing parenthesis? So we need to keep on popping the elements. We have to add a while loop which will keep on popping the elements till the corresponding open parenthesis we see, right? We will keep on popping. Either we will keep on popping the elements, either the stack is empty or we see the corresponding open parenthesis. So there will be two conditions. First, the stack should be non-empty and the stack stop should be not equal to the open parenthesis, right? So we need to keep on popping the elements and add it to the output. we have to keep on popping the elements and add it to the output till when? Till we find the corresponding open parenthesis of which the current closing parenthesis is. Correct? So the output dot append, we will add temp, or you can also move it in a single step. No need for a temp. This is also fine. Okay. And now finally we will get rid of this open parenthesis from the stack, which is stack dot pop, just a pop. We won't be adding it to the output because this is done. We are done with the corresponding open parenthesis. Whatever was present in that corresponding parenthesis is already dealt with, right? For instance, let's have a dry run for this case. You have this open parenthesis a plus b and the closing parenthesis. For now you can forget this. What we need to do in case we find an operator, leave it for now. We have added only 3 conditions. Fourth one is pending. So if we encounter the first parenthesis, we will add it to the stack. This is how the algorithm works, right? Then whenever we see an operand will straight away be added to the output. Correct? Then a plus. So for plus, hold on. Then it's a b. If another operand occurs, we'll add it to the output. And finally, the closed parenthesis. So the closed parenthesis, in case of a closed parenthesis, we will keep on popping the elements till the corresponding open parenthesis we encounter, and then we will remove the open parenthesis and carry on with the conversion, right? Okay. So now let's see the last condition, which is what if we encounter an operator, right? And in this condition we also need to check for the precedence. So we will the operation will be done in such a way that it should see the condition is to pop the topmost operator from the stack is the precedence of the top is, if it is greater than the precedence of the current token, we will pop it out, right? So for that we also have to maintain some sort of precedence to decide whether the topmost operator, whether the precedence of the topmost operator is greater than the current token. Okay. So for that, let us maintain a dictionary or a hash that will tell us the precedence. So for simplicity, let's assume we are only dealing with 4 type of operators: plus, minus, multiplication and division, right? So for plus, let me give it precedence as 1. For minus, precedence remains the same. Then the precedence will be larger or greater for multiplication. Let's assume it is 2. It is just to compare that if plus is encountered, I am able to check the precedence of plus should be not plus. If multiplication or division is encountered on the top of the stack, then I have a mechanism to decide that its precedence is greater than 2 is greater than both of them. That's it. So you can take any precedence of your choice, but the precedence of multiplication and division should be greater than plus and minus. So 1 and 2 will do the job for us. Okay. So now what I have to do? I need to check first that the token should be among these keys: plus, minus, multiplication and division. Otherwise the incoming expression is the corrupted one, right? So if token is among these 4, I can directly write it as pre. So if it's an operator, then what is the next action? We will start popping out operators from the stack, but there will be a condition: the precedence of the topmost operator in the stack should be greater than the precedence of this token. Then only we will pop, otherwise will not. Otherwise we will just push it, right? Okay. So while stack should not be empty, right? And while stack should not be empty, and the same condition, this should not be the opening parenthesis, and finally the precedence of the topmost element. This is stack -1 is the topmost element in the stack. Its precedence should be greater than or equal to precedence of my token. Correct? If the condition holds, in that case, just repeat this. Remove an element from the stack and add it to the output. Remove an element from the stack and add it to the output. Clear? Okay. And once we are done with removing all the higher priority operators from the stack, we will add the corresponding token. We will push the corresponding token to the stack. This token will be appended. Oh, it will be like this to the stack. Correct? It will be like this. Yeah, now it's fine. Is it fine? What we have done here, we have checked that this token should be among these keys which are present in my hash map. So it won't work if it is some other operator apart from plus, minus, multiplication and division. Now the stack should not be empty. Its top should not be the opening parenthesis, and the precedence of the topmost operator in the stack should be greater than or equal to the precedence of the corresponding character or token, which is an operator. If this holds, remove the top and add it to the output. Once we are done with removing of all the operators having higher precedence than my current one, I will just add the current token, the current operator, to the stack on the top of the stack. That's it. So it says like this. So now what if multiplication was already present in the stack and we encounter with plus? If we encounter with plus, first remove multiply and add it to the output, and then push plus. This is what the last if condition and the while loop will do. It will get rid of all operators which are having higher precedence than the current one. Okay, but this won't be the case if there is an operator having lower precedence than the current one. What if the current one was asterisk, was multiplication or division? In that case, we will just add it over top of the current operator. Why? Because its precedence is lower than my current operator, right? So asterisk will be added on top of it, and we will continue the process, right? Okay. Alright, so we are done with all 4 conditions. There are only 4 possible scenarios. Now the last one. Now what if we have completed the traversal of all the characters present in the expression, and even then there are certain elements or certain operators present in the stack? In that case, we'll just get rid of them. While stack is non-empty, remove the top and add it to, pop the topmost element and append it to the output, right? So this should do the job. Let's see. In to post, and let me give the same example that we solved in the class. A plus B times C plus D. Okay, so what will be the postfix of this? The postfix would be A, B plus, then C, D, again plus, and finally multiplication, right? Let's see the output. Oops, there's an error. Okay, we forgot passing token to this append. All right, now let's check. Okay, we forgot returning output as well. Yeah, finally return output. And in this case, output is in list. So if we want the output to be a string, we can convert it to the string by using join. Okay. All right, here's the output. So this is the correct postfix conversion of the given infix expression. We can check for a few more. Now, what if the expression is without parenthesis? Say a plus b plus c plus d. Then let's have one more. A plus b asterisk c, and then a asterisk b plus c. So if you see the last two expressions, there will be the role of precedence. Here a plus b asterisk c, in this case b asterisk c should be evaluated first. So the converted postfix expression should look like this. There will be b, c, asterisk, then before that it will be a, and finally it will be plus after that, which tells us that b and b asterisk c should be calculated first, then whatever the result is should be added to a. And in the last one it should look like this. A asterisk b should get calculated first. Why? Because the precedence of multiplication is higher than plus, right? So it will be a, b, asterisk, then c, and finally plus. Let's see the output. Correct. So the precedence are like taken care using the numbers. We have given higher precedence to asterisk and division, and lower precedence to plus and minus. So yeah, it is working as expected, right? So this is the corresponding postfix conversion. This is the corresponding postfix expression of the given infix. So now few problems for you guys and homework. So define like define the functions for the infix to postfix. We have seen for infix to prefix, infix to prefix, we have already seen how, like in the class, how you can implement this conversion. And second, infix to postfix, this is conversion, so there can also be expression evaluation. So give the evaluation of postfix expressions, right? This is also simple. You have given a postfix expression, you have to evaluate, so you will be converting it into an infix and then evaluate, right? So idea remains the same. So we have already discussed the algorithm to evaluate the postfix as well as the prefix expressions, because infix is straight away you can easily calculate. Given the values of each of the variables, you can directly calculate the infix expression, but it is difficult just by seeing the expression. If it's given in the postfix or in prefix manner, it is difficult to get the value. So define the function to evaluate postfix expression and do a conversion infix to postfix in the homework.